My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 534. In this lecture, we will try to understand logistic regression and perceptron. Logistic regression, basically a plane separating positive points from negative points. We understood logistic regression from geometrical perspective, and also from probabilistic perspective. From probabilistic perspective means it's nothing but Gaussian naive Bayes with some variation. Now let's try to understand logistic regression from neural network perspective, from a perspective of a neuron. So mathematically speaking, let's understand what does logistic regression means. A logistic regression, given any point xi, if you want to predict its yi, let's call the predicted value is yi cap. Yi cap is the predicted value of yi. So in logistic regression, what happens? Yi cap equal to sigmoid function of w transpose xi plus b. Given a bunch of data, capital D equal to xi comma yi, train logistic regression, what do you find? Find w and w's and b. Let's assume your point xi belongs to rd, then your weight vector w also belongs to rd. W belongs to rd and b is a real number. In a nutshell, this is the core relationship between xi and yi cap. If you've forgotten this, please go back and revisit logistic regression chapter where we discussed in detailed manner. Sometimes we may drop b. Sometimes we may drop this particular, which one? We may drop this b, isn't it? Sometimes we may drop b, but let's keep b for completeness, just for completeness. So if you think about this, if you think about whole thing, the structure we have here, w transpose xi plus b. If I expand this structure, this w transpose xi plus b, what do we have? I can write this as yi cap equal to sigmoid of sigma j equal to 1 to d wj xij plus b. What is this? Point xi is a d-dimensional point where xi is represented a vector of size d, that is xi1, xi2, so on xid, and w vector is nothing but w equal to w1, w2, so on wd. If I just take this, what is my my output function? Output function from neuron, f of function of sigma j equal to 1 to d wj xic, isn't it? What does it mean? What is this? Just see, this is, what is this? Functional form of a neuron. Output equal to this, we already discussed this in our previous lectures. What is my o? O is nothing but output, and f is activation function, wi's are weight vectors, xi's are inputs. We saw this as functional form of a neuron. If I want to represent logistic regression with a neuron, I can do it like this. So I will have neuron here, isn't it, with a function f, and these are the inputs and this is the output, isn't it? All these are inputs. What is this? xi1, xi2, so on xid are the inputs. I'm just trying to represent, isn't it? This is the, what is the formula? Here xi1, xi2, so on xid are inputs, yi cap is output, f is sigmoid function, isn't it? If I'm trying to represent this as a simple neuron, if this function is sigmoid function, what do we want? We want a form like this. We want form like this, yi cap equal to sigmoid of j equal to 1 to d wj xij plus b, isn't it? What is our output function or neuron? This is, yes, I made sigmoid is same as f, isn't it? I made sigmoid is same as f. And what do we do with we have a simple hack. We will say in addition to all these inputs, I have an input which is equal to 1, isn't it? I have an input which is equal to 1, and this is my weight. What is this? This is input of input 1. What it says, input 1 with weight b, isn't it? Now what happens? This is my W1, W2, W3, WD, so on, weight B. Is it weight B, isn't it? W1, W3, so on. This is my weight B. So now let's write the formula. My formula is, what is my formula? My formula is yi cap equal to f of W1 xi1 plus W2 xi2 plus so on WD xid plus 1 into B, isn't it? What is this? Yi cap equal to W transpose xi plus B, isn't it? If my f is sigmoid, if my W1, W2, WD are my weights on these edges, on these input edges, if you think neuron perspective, these xi1, xi2 are dendrites. B is also weight. Weight. Output will be by just applying sigmoid function. So this is the neuron interpretation. This is basically taking logistic regression and representing as neuron, and this is how we represent it. It's very simple. In logistic regression, what is the task? When you train logistic regression, you should find the values of W and B. So in a neural network or in a simple neuron like this, what are given? Given a data set D equal to xi comma yi, and task is to find the vector W's and B, where I equal to 1 to D, because W is a D-dimensional vector. I request all of you, please go through this lecture. If you have any difficulty, please keep a comment so that I will continue my discussion in my next lecture also, that is in lecture number 535. Thank you very much.